previously discussed, um, I guess it was just a lot of algebra questions. We didn't do much teaching. So we were looking at how to solve word problems dealing with algebra and how do we break it down? How do we figure out how many equations we need, how many variables we need, and all that type of stuff. So we're going to continue with that topic for today as well. We have some more examples here. And in terms of the fractions, we have algebra and fraction mixed together as part of your homework. So that's going to be given to you today, and then you complete it, and we show it for next week. So for now, let's do the homework from last week. Let's check out a few of the questions that were given. Here's the first one.
I
Another
have
one
a
of these.
question. Did the dash just mean like equals? Because that's just what I assumed it was. Like equals.
Oh yeah, this dash right here before 12.
Yeah.
Yep, that would be the equal sign.
Okay.
It's a little weird, but yeah.
I got for the circle I got 17.
For the circle, we got 17. All right, perfect. And how did we solve this?
So the square and the square because it's 12 divided by 2, that's 6.
Excellent. So we can say 2s, s equals square equals 12. And
And then
then, yep,
um 6 times 3 plus 3 equals 21.
all
So
right.
that's how I knew that the triangle was 3.
All right, excellent. So when we're looking at that second line, we're going to deal with s for square, t for triangle. So s times t plus t equals 21. So we want to solve these using algebra. So how can we solve this question here? How do we solve for t?
So ST plus T equals 21. So, I mean, couldn't you just cancel? Oh, no, never mind. Because it's not, T, because we know the square is, 6. So you could do 20, because you gotta like do the reverse. You could do 21. Um, no, that's how you'd make sure that your answer is right. Never mind. Um,
So I'll give you a hint. You're on the right track when we are talking about using the previous line. So we already know the value for the f. So we can use that in this line as well. So we can say 6t plus t equals 21. So now what do we do?
okay.
6t plus,
So 16T plus T equals 21. I mean, I didn't really use algebra to solve it. I just kind of plugged like different. I just plugged 3 in. So I did 6 times 3, which is 18, plus 3 equals 21.
yeah, that's, trial and error. Of course, it technically works as well. It's not really the best way to solve things because we want to incorporate some of the theory that we're learning. So here we have our first equation. Here we subbed in s. Now we simply have 6t plus t. So we have 6 of something, then we add another one. So that equals 7t. Make sense?
I'm confused about like how you said if there's like 6, then you gotta, you know.
Yep.
I
So
think
pretend we have, instead of t, pretend it was like something that we can hold, like an apple. So if I had 6 apples, and then I add one more apple, I'm going to have 7 apples. So each t represents however many objects we have. So at first I have 6t, meaning 6 times however many objects, 6 times a single apple, so 6 apples, plus one more apple, aka plus t. So now I have a grand total of 7 apples.
hmm
Another way to say this is 6t essentially just means t plus t plus t all the way to 6 times. Sorry, this should be an equal sign. All right, there it is. T plus t plus t plus t, whatever, all the way to 6. So 7t
hmm
is going to be the same thing plus one more.
Oh, okay. No, no, that makes sense. That makes sense.
All right, perfect. So 7t equals 21. Pretty simple at this point. 21 divided by 3. What is that? 7? Yeah. So now we have s equals 6, t equals 7. We have one more equation here. Let me just shrink this box and do another one. All
Um,
right. So what is the next equation? How do we write it out?
6 times 3 minus, I guess, the y for the variable times
Yeah.
6
So
equals 6.
all right. So now let's do that again, but let's incorporate our variables only. So don't put any values in.
I guess s times t.
Yep.
So st minus, well, I mean, it's a circle. So c, times, times s equals s.
All right. Perfect. Now we can sub in the values. So we know s is 6. So we got 6. T is 7. So that's 7. Do we know C?
No.
Not yet. All right. So leave C as it is times S. So that's 6. So it's going to be 6C equals S again, which is 6. All right. Now we have one variable here. Looks pretty simple to solve. How do we solve this? Go step by step.
Um, so I mean, because it's 6 and 7, that'd just be 42, right? So
Yep.
42 minus 6c equals 6.
Perfect.
And then, I mean, 42 minus 6. Okay. I mean, wouldn't that just be, never mind. That wouldn't work.
Yep. So you're on the right track. You said 46. Sorry,
Wait, so
42
couldn't you
minus.
just get rid of the 6 on one part of the equation and then just subtract 6 on the other part of the equation to make like um 36 minus c?
So we can't do 36 minus C. So this is a multiplication. In order to get rid of a multiplication, we got to do division. So
Oh.
we can get rid of this guy because this is simply just addition. So let's do that first. So we have 42. Actually, let me do it this way. We have negative. Okay, that was weird. We'll do 42 minus 6. So we'll move this 6 to the left. So now it's minus 6. And then we'll move this 6 minus 6c to the right. So it's positive now. So we have positive 6c. 36 equals positive 6c. Now, how do we do this last step?
I guess you just do 36. So I mean, if 6, couldn't you get rid of the 6 and then just do 36 divided by 6?
Yeah, yep. So this is a perfect
So
step. So
that's
36 divided by 6 is 6. All right.
oh
So are there any questions here? We got all three of our answers.
yeah. I just realized on that problem I wasn't using PEMDAS. I was
Oh,
just like doing it like just like right, like left to right.
oh, okay. I see. Yeah. So we got to make sure we incorporate that PEMDAS in our answers as well. And the big thing is because we're learning about algebra, we got to, try to practice using algebra to solve our equations. So the best way to do that is just look at what you have, what's given to you, and then see if you can represent things using variables. So this diagram is pretty easy. It's pretty straightforward. We can represent each diagram as a variable. In a word problem, that's going to be a little trickier. That's going to involve a little bit more thinking. But yeah, I think we got a hang of the word problems last week. So we'll continue that this week as well. We'll practice that some more. Let's check this question out now. This says to solve each equation, and it looks like it's one variable for each equation, so it should be pretty simple. Let's do every other one. So we'll do A and C for both of these questions.
Okay, so for A, I got K K equals -7.
Let's do
Oh no,
9.
sorry, that's for 10.
Yeah.
Never mind. It's R equals 2.
R equals 2. Perfect. So we got 6R plus 6. We can move that 6 over, so it's going to be equals 12. R equals 2. Excellent. Let's do question C, 9C.
G equals 4.
G equals 4. Perfect. So we got 75. 9G equals, what does that equal? 36. G equals 4. Perfect. All right, 10A.
I got K equals -7.
K equals -7. So we've got a negative number here. So we have -17. And we have +4 on the other side. So let's move those guys together. So it equals this on the left side. Your right side, 3K stays positive. Minus 21. 3K. Yep, looks good. Your answer is perfect. -7. And 10C.
I got X equals, wait, no, yeah, X equals -3.
All right, let's check this out. 8X equals, move the 7 over, so it's this plus 7. What does that equal? 24, -24. X equals, yep, very good, -3. All right, excellent job. So pretty simple when we're working with one variable. Now, back to our word problems here. Let's see if we can tackle this one. A website received 9,747 visits during the first month of its launch. The third month witnessed 3 times the number of visits than the second month. And if the website received 13,455 visits over a 3-month period, how many visits did it witness during the second month?
Okay. So, I mean, I'm not sure if this question was algebra, but I mean, I didn't really use algebra to solve it. So first I did 13,455 minus 9,347, which was 4,108. And then cuz I knew that the third month is 3 times the number of visits in the second month. I know that to find how much people visited the second month, I need to do 4,108 divided by 4, which is 1,027. So my answer was 1,027.
1,027. So that ended up being your final answer. How many visits during the second month? All right, yep, makes sense. All right, so let's go through this. The website received 9,000, blah, 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 for the first month. Third month witnessed 3 times the number of the visits in the second month. And this is your third month. Okay, so let's label these to start off. So first month equals, and then second month, and third. So we have 13,455, 9,347, and this is a big question mark. If the second month, okay, so the third month witnessed 3 times the number of visits in the second month. So instead of leaving it as a question mark, we can say T divided by 3. So T had more, third month had more visits than the second month. So I'm going to say third month divided by 3 is equal to this month. If that's the case, then we don't even need the first month information. Received 9,000 during the first month. The third month received 3 times the number of visits than the second month. Oh, this is not the third month, this is over 3 months. Okay. So total of 3 months. Yeah, sounds about right. So yeah, makes sense. So this would be your value for month 2 and month 3. Okay. So this would actually be value of month, I'll say second and third month combined.
Mm-hmm.
You see how that works? So this is the total of from 3 months. This is your total of 1 month. In order to get the total of 2 months, you subtract them.
Yeah.
So this is going to be your total of second and third. Therefore, what we got to do now is incorporate our little bit of algebra. We got to say second month equals, so we have third plus second, and that equals t plus t divided by 3. Remember?
Mm-hmm.
All right. So this is actually going to be total of 2 months equals second plus third. Total of last 2 months. Sorry, I keep editing it while I go. So the last 2 months is equals to the third and second, t plus 3. This, as we already know, is 4,108. All right. So now this is our equation. This is what we want to work with. We want to find t. After we find t, we plug it into this to find the second month. So how do we find t?
So to find P, I mean, what I did was just divide by 4, cause like plus P divided by 3. Well, no, couldn't it just be like S plus S times S times 3S or something? Couldn't that also work?
Yeah, that's true. We can rearrange this. We can change this to S instead. Very good point. So we can say 3S plus S. All right, excellent. That's a great way to do it.
Because then that makes it obvious that it equals 4S, right? So it makes it logical to do 4,108 divided by 4.
Yeah, that sounds good. That's a good way of working around it. Nicely done. So that equals 4S, and S equals what you got? 1027. All right. Excellent. Excellently done. Yeah, so your thought process here was perfectly done. We just need to, like label things step by step, go through it step by step. But overall, excellent answer right here. Very well done. Let's move on to our challenge questions now. All right, so back to these word problems here. This one says 3 children each contributed towards a birthday present for their mother. The oldest contributed 3 times as much as the youngest, while the second oldest contributed 50 cents more than the youngest. If the present costs $10.50, How much did each contribute?
So, I mean, we kind of have to write down our information. So, like the oldest, I guess we can just put like um oldest equals youngest times 3.
Oldest equals youngest times 3. All right, so youngest, we'll just put x. We'll use x for everything. So we'll do 3x. So
And
that
then
means youngest equals x.
okay, and then the middle, the second is just it equals x plus 0.5.
Very nicely done. And one last piece of information.
The total is $10, 10.5.
All right, excellent. 10.5. And using this information, how can we solve? What do we need to solve? How much should each contribute? Okay, so how do we solve this?
I mean, we'd have to create an equation. So maybe, I guess like because the youngest is x. I mean, I guess I do like x plus s plus o equals 10.5. So just like all of them equal 10.5.
Yep, very good. So all of them included here, 0.5, and then the oldest is 3x equals 10.5. Excellent. Now, how can we work through this?
Oh wow. I think I mean you gotta find the value of x. So oh geez. Would you like would you maybe like work backwards or something from 10.5?
You wouldn't have to work backwards here. So this is pretty similar to one of our previous questions, the one with the shape. When we have x a bunch of times and they're adding up to each other.
Oh wait, so I got it. So like you just erase like the other x, it'd be 4x plus in parentheses 6 plus 0.5 equals 10.5. It's like simplified ones.
Yep. Okay. So this is a good first step right here. Nicely done. There's no errors. But you can simplify this one more way. You can go one step further.
5x plus 0.5 equals 10.5.
Yep, perfect. So that is the last step even though there's a bracket here, there's no multiplication happening, it's just addition. So we can still add them like we added this guy.
Okay, so it'd be 10.5 minus, so 10.5 minus 0.5 is 10. So then 10 divided by 5. So then that because you got to do 10 divided by 5, that means x equals 2.
Excellent. X equals 2, so this equals 2.
The youngest made 2. The second gave 2.5.
Oh, yeah. 2 plus 0.5 equals 2.5.
The oldest gave $6.
All right. Excellent. Nicely done. So this is a great first step right here. And we simplified it to get a shorter equation to work with. Very well done. So those are the two key steps anytime you're working with a question like this, is to simplify your expressions. I guess we haven't really practiced simplifying our expressions too much so far, but today we've done it multiple times, so we can keep this up. I'll probably include some more of these for next time. We got one more question here. It says, at a recent job fair, there were 2/3 as many inquiries about jobs in healthcare as in electronics, and 50 less inquiries about teaching as electronics. A reported 430 inquiries were made about the three fields. How many inquiries were made about teaching?
Okay, so electronics, let's just say it equals, I mean, actually, we'd probably need to make, no, yeah, electronics makes the most sense because, all of them are related to electronics. So I guess electronics equals X. So, um, so the amount of healthcare inquiries is X divided, well, no, it's just X times two over three.
Yep, very good. So it's 2/3x, or
And
actually it'd be 2x divided by 3.
so, and then teaching, it's X minus 50. So,
50 less inquiries about teaching as, yep, all right, x minus 50. Perfect.
and then the total is 430.
Excellent. And now, how do we make an equation out of this?
X plus two, plus 2x over 3 plus x minus 50, and like put the x minus 50 and the 2x over 3 in parentheses,
Okay.
equals 430.
Excellent. Equals 430.
Okay,
And now, what do we do?
so I think the first step is, I mean, I guess 2x minus 50 plus 2x over 3.
All right, nicely done. So 2x minus 50 over here. And let me just do it at the beginning. We have 2x over 3. That would be plus 2x minus 50.
Okay.
All right, so we have a little bit of a dilemma. How do we work through this random fraction?
I mean, technically, isn't it just, yeah, it is just like 2x divided by, well, no, it's just technically 2x divided by 3 times 2.
2x divided by 3. Where does the times 2 come in? Because this is going to be plus 2.
Oh, no, because that's just what the fraction equals. So, I mean, I just do I mean,
I'll give you a hint here. So let's see if we can solve this. 2/3 plus 2.
two, two, oh, 2 and 2/3 x, I guess.
2 and 2/3. Okay. Let's try to use, what's it called? An improper fraction. So that would be a mixed fraction. So
Oh,
2 and 2/3 mixed. How do we do the improper fraction?
8 over 3.
8 over 3. Perfect. So that would be 2/3 plus 6 over 3 equals 8 over 3. Excellent. So let's use that same knowledge to this problem above.
Okay. Wouldn't it just be 8 over 3? Wait, no, 8x divided by 3?
Excellent. 8x divided by 3 is perfectly done. And then we got this.
Okay. So I guess, oh, what do we do next? You can do that next. Isn't oh no, because that'd just be pushing us back. 8x divided by 3. It's just 2 and okay, yeah.
So here's the first step. Let's get rid of this minus 50.
Wait, if you got rid of the minus 50, wouldn't you just do equals 380?
So that would be
No,
4
400.
over, he turns positive.
Yeah, 480.
All right, perfect. 480. Now, we have two operations happening here. We have a division and a multiplication. So we got to do the reverse in order to find x. So let's get rid of that 3 first. That's going to end up being 480 times 3. So what does that look like?
8x equals 1,400, I think 40.
Yep, very good. And let me just take this out here. And the last step, we have x equals
1,000. Okay, I'm gonna use a calculator for this one. That's very okay. 1,440 divided by 8. So it's 180.
All right, very well done. So x equals 180. Now we have the second part of the question. Let's move this here. All right. Where are we at? X equals 180. Teaching equals
120.
very good. 120 or 130?
Oh no, that's teaching. Sorry, I was thinking about healthcare. Yeah, 130.
All right. So let's see. The question says, how many inquiries are made about teaching? Okay, yeah. So we just have to find teaching only. So teaching equals 130, which is absolutely correct. Very nicely done. Let me just delete that. All right, so I think that's about it for this question here. Are there any questions about our solution?
No.
All right, perfect. So let's go back to our lesson plan here. Looks like all we're going to do for today's lesson is mostly just single operation algebra. So in this example here, Simone uses a different spring in her experiment. The equation that models this new spring is F equals 12D, where F is the force and newtons needed to stretch or compress the spring at distance of D in centimeters. Simone applies a force of 84 newtons to compress the spring. What is the distance in the spring compressed? Oops.
Okay. So
what do we know so far about this question?
So F is okay in newtons. So I'm confused what it means by F equals 12. Oh, that's distance. Oh, never mind. That makes sense. So when someone applies what distance is this spring so wouldn't F just be 84 times 12? No, 80. Wouldn't that just be 84 times 12? I'm confused.
So here we have a few pieces of information. So the first thing we want to make note of is the formula, the equation, which is F equals 12D. And the next thing we know is F equals your force, which happens to also equal 84 newtons. And D, we don't know. We got to figure it out. So essentially, we have this ready for us right now. We have 84 equals 12D.
Mm-hmm. Okay, so 84 equals 12D. Oh, so wouldn't it just be 84 divided by 12?
Yep, perfect.
7.
84 divided by 12.
D equals 7?
7. All right, so 7 is our answer, and we're going to include the units, centimeters. So are there any questions about how we solve this?
No, I was just a little bit confused on the wording.
Yeah, so yeah, this wording has a little bit of physics involved here, so it would sound a bit confusing.
My science grade is my worst grade in school, so.
No worries, no worries. We're not going to have too difficult of wording, so it should be okay. But yeah, this is pretty straightforward, just one operation in one variable. Let's do another question here. All right, so for the month of January, the average afternoon temperature in Edmonton is 1/3 the average afternoon temperature in Yellowknife. The average afternoon temperature in Edmonton is -8 degrees Celsius. What is the average afternoon temperature in Yellowknife? So what do we know so far?
That the temperature in Edmonton is 1/3 the temperature in Yellowknife.
Yep, very good. 1/3 of Yellowknife, we'll call it Y.
Wait, so wouldn't just like 1/3 just be divided by 3?
Yep, we can say Y divided by 3. Both of them make sense. And the temperature in Yellowknife, we'll call it Y. And what else do we know?
That the temperature in Edmonton is -8 degrees.
All right, perfect. Temperature in Edmonton is also -8 degrees. I'll just leave it at -8 for now. So how do we solve for Y?
I'm just guessing, but is it 24 degrees Celsius?
Yep, it's a pretty good guess, but how did you solve that?
Well, I mean, I was kind of confused on the wording on 1/3, but because I know that Yellowknife is north of Edmonton, I just assumed that you'd have to multiply. So
Yeah.
-24 Celsius.
All right. So, pretty good answer right there. We do have to multiply. That is correct. But let's look at our algebra here. So we already know this information right here. Y over 3 equals -8. So the temperature in Edmonton equals -8. And how do we represent the temperature in Edmonton? We can call it Y over 3. So let's write that down. Y over 3 is -8. And Y, whoops, wrong letter. Y, to find Y, we simply just multiply by 3. So we have -8 times 3. That equals -24 degrees Celsius.
Mm-hmm.
Alrighty. So pretty simple, straightforward. Let's check out. Okay, so this is just a lesson, I guess. There's no actual questions here. Essentially, they're just doing exactly what we did so far. When we have our fraction, whatever we do to one side, you do to the other. So if you want to cancel out that divided by 9, you would have to do the opposite, which is multiply by 9. You multiply by 9 on the left side, then multiply by 9 on the right side as well. Pretty straightforward. We've been doing this so far. Oh, number 4 is actually a question. Let's check that out. Oh, no. All right, so this question says Raj is solving the equation n divided by 4 is n divided by 9 is -4. And this is his solution. Is Raj's solution correct or incorrect? Explain. What do you think?
So, Okay, so n equals, is it saying like the entire problem equals -4, or is it just saying n equals negative? Oh,
So he's saying n divided by
wait,
9
so wouldn't
equals
n
-4.
be -38? Like 36?
N should be -36. All right, so let's solve that ourselves. So we've got n divided by 9 equals -4. N equals -4 times 9, -36. So he is incorrect because he got 36. So why is he incorrect?
Because he forgot to add the negative sign, I
Yep,
guess.
pretty much. So it's not that he forgot to add it, but he incorrectly added it. So as you see in his second line here, he incorrectly multiplies by -9 for no reason. It should have just been 9.
Oh.
So incorrect because Raj multiplied by -9 when he should have multiplied by, I'm just going to put the positive sign, +9. So multiplying, I can't type, multiplying by +9 is necessary to cancel out the +9 in n divided by 9. All right, so pretty straightforward. You got that well done. You got that answered correctly. Yeah, so one of these questions might appear in your class or on your test. Pretty much just asking you to explain your thought process, not too much math involved. Let's move on to a couple other questions here. The height of a great gray owl is 5 times the height of a pygmy owl. A great gray owl can grow to 85 centimeters. Model this problem with an equation of the form ax equals b. All right, we can do that. Let's check this out.
Wouldn't it just be 85 divided by 5?
Sure. So how did you get that?
Well, cause a gray owl is 5 times the height of a pygmy owl, and if a gray owl is 85 centimeters, then you'd have to divide 85 centimeters by 5.
All right, excellent. So gray owl is 5 times the size of the other one, pygmy. So we can say this. Okay, pygmy equals p, and gray owl is also 85. All right, so like you said, simply divide by 5, which is what we have up here. We have f5p equals 85. P equals, what does this end up equaling? It's like
17.
17. Excellent. All right, so that is part B. What is the height of the pygmy? 17. So we'll just write that down. The height of the pygmy owl is 17 centimeters. All right, nicely done. Let's keep it going. Another one of these temperature questions. Let's just move this a little bit. All right. For the month of January, the average afternoon temperature in Calgary is 1/4 of the average morning temperature. Of its average morning temperature. The average afternoon temperature is -4 degrees Celsius. What is the average morning temperature?
So the afternoon temperature is 1/4 of the average morning temperature. So it's like 4 times like colder in the after. Wait, it's 5 times colder. It's 4 times colder in the morning. Oh, that makes sense. Okay, I think it's -16.
-16. All right, so let's do morning is m divided by 4. And we also know that this equals -4. Morning equals m. So yeah, pretty much the same question over and over again. Then we just do multiply by 4, that's negative 16. All right. Yeah, nicely done. Not too difficult at all. Morning temperature equals negative 16 degrees Celsius. Let's write that down. All right, let's check out the next question here. Nakasuk's snowmobile can travel 13 kilometers on a liter of gas. He's going to visit his aunt in a community that is 312 kilometers away. Nakasuk wants to know how many liters of gas he needs to travel to his aunt's community. Write an equation in the form of AX equals B to represent this problem. So AX equals B is the same formula that we've been doing over and over again. We have one variable, one operation, which is division, and it equals something. So how do we solve this?
So, so is it just asking, like, it's asking how much liters of gas he needs? So it's just 312 divided by 13.
Yep, very good. So 312 divided by 13 is the correct solution here, but we need some more information. So
And
try to
his
incorporate our variables. Remember, we have to do this. AX equals B.
AX equals B. I mean, I guess just like 13 times the amount, the 13. Wait, no, that doesn't make sense. Wait, so like 13. Oh no, never mind. No, yeah, it does. 13 times. Wait, I'm having the hugest brain fart. I think it's 3. Oh, oh my God. So I have to use variables to create a problem. Um, what does so 13 times 24 equal no, because there's no does it do all the numbers have to be variables? Like every number?
Technically you can find a way to make every number variable, but you just have to include one variable.
So I guess 312 divided by 13 equals G, which is like per liter of gas.
Yep. 312 divided by 13 equals G. Yep. So that does make sense.
Is this a Canadian textbook?
Yeah, seems like
I
it. A
could
lot
tell
of
because
Canadian.
no American city names.
Yeah, so a lot of Canadian names, a lot of Canadian kilometers, liters, all that kind of stuff, all that fun stuff. So, you're correct. 312 divided by 13 equals G. So G equals G equals gas. Another way of representing this is saying your total distance, I'll just call it distance, equals your, let's see. How do I phrase this? Distance equals, let me just write this down. So the final answer is going to look like this. 312 equals 13G. I guess we can call it rate. Rate is usually how much we're dealing with. Distance equals, all right, whatever. We can just forget about this. So as long as we know that G is the amount of gas, 13 is how much kilometers can travel on 1 liter of gas. Yeah, that is the rate. That is the rate. The rate is kilometers per 1 liter. All right, so distance equals rate times gas. Or if you want to write it differently, you can say RG. D equals RG. We already have D. We already have R, our rate. We just need to figure out G. So this is absolutely correct. This last equation right here is how we write it in an AX equals B format. AX is on the right, B is on the left. All right, so overall though, how many liters did he need to make this trip?
24.
All right, perfect, 24 liters. So are there any questions with how we solved it?
No, it makes sense. I had a huge brain fart on number A.
Yeah, no problem. That, anytime we're throwing in a new phrasing like AX equals B, it does kind of trip us up. But we're all good. Essentially, it's the same steps that we've been doing over and over again. So it's just worded a little differently. So let's look at this question now. Lucy is making, let me put this in the middle. Where's the middle? All right. Lucy's making 4 pairs of mitts. She has 144 centimeters of trim to sew around the cuff. How much trim does she have for each mitt?
Oh, so is it just asking me 144 divided by 4?
Yeah, pretty much. So she's making 4 pairs of mitts, 144 total trim. Okay, so total trim equals 144. She has 4 pairs of mitts. So this is actually going to be 8 mitts. So it looks like we're going to have to divide by 8 instead.
Okay. So it's 18. I used the calculator. It's 18.
18? All right. Awesome. So this is your value of trim per mitt. And if we want to write this differently, we can say your total trim, 144, equals, what is our value? 8 mitts times, let's just say trim. So in order to find your trim per mitt, you're going to have to divide our trim per mitt. Does that make sense?
Yeah.
All right. So let's move on. Let's do the next question here. Another word problem. People can be left-handed, right-handed, or ambidextrous. The number of boys in Canadian secondary schools who are left-handed is about 1/7 of the number of boys who are right-handed. About 11% of boys are left-handed. Write and solve an equation to determine the percent of boys that are right-handed.
It'd be 11 times 7.
11 times 7.
Because 1/7, there's like 7 times more right-handed boys than left-handed boys. Because it says 1/7.
Yep. All right. So let's write down what we know so far, because I think we are missing one piece of information. So people can be left, right, or ambidextrous. So let's say a total number. I don't see it. Number of boys in Canadian schools who are left-handed. Left-handed equals 1/7 of right-handed. I'll do R divided by 7. About 11% of boys are left-handed. 11% of total. So right-handed equals R equals question mark. Okay, so since left-handed is 11% of total, that means 89%. equals right and ambidextrous. I'll just call it ambi. R divided by 7 equals that.
Mm-hmm.
We don't have any total, so we just have to write and solve an equation to determine the percent of right-handed.
Well, I mean, it's 77%, so 12% are ambidextrous.
77% equals right, and then 12% are ambidextrous. So how'd you end up getting 77 equals right?
Because 11 times 7 equals 77.
All right, yeah, so this is at the top here. Forgot about this. All right, there it is. So this is our AX equals B formula. That's what I was looking for. So we get AX equals B. R equals 11 times 77, sorry, 11 times 7, which equals 77%. All right, excellent. So I completely forgot about this. We already wrote this down. I was thinking like, oh, we're missing some information. Yeah, so it looks like we're okay. And if we have actual values for how many boys there are, then we can figure out the actual number instead of leaving it as a percent. Got a couple minutes left. So let's see if we can do one more question. Looks pretty simple here. The area of a triangle shown is 30 centimeters squared. Write and solve an equation to determine its height. So area is 30 centimeters squared. Height, we don't know. What do we know about this triangle though?
Like the base, like the bottom part's 12 centimeters?
Yep, perfect. And is there anything else that we know, just in general, about triangles and area?
Um, uh, oh no. That they're half a square? No, never mind. That's stupid.
So if we have a triangle and we're trying to find the area, we know the formula will always be the same thing. It's always going to be base times height divided by 2, or BH divided by 2. So now we have this formula, and I'm going to write that down here. 30 equals BH over 2. And we know B, so we can plug that in. 30 equals 12H divided by 2. Now, how do we solve for H?
It's 5 because 12 times 5 divided by 2 equals 30. So
All
I
right.
mean 30 times 30, so it's like 30 times 2 is also 60, so.
Yeah, all right. Excellent job. So we were working backwards. Another thing we can do before we make any steps is to simplify this a little bit. So instead of saying 12 divided by 2, we can simply say 6. They both equal the same thing. Now we can just do divided by 6 equals H. Whoops, H. H equals 5. So the height would be 5 centimeters. All right. Not too bad. Pretty straightforward. So I think these were all one operation, one variable. Moving on, I think we're going to work on some double variable equations. That's for next week's class.
Homework?
For your homework, you have a few slides. So I'll leave it here for you to screenshot.
Okay. Oh, geez. I accidentally turned off my phone.
No problem.
Pressed the wrong button. Okay. Got the first one.
All right.
Got the second one. Got this one. This one. Yep.
All right. So these questions, of course, we haven't done a lesson on how to solve these per se. We've done a little bit of similar stuff. Try your best to work on all of them. If you have any questions, that's totally fine. We'll work on it together at the beginning of next week, okay?
Okay.
All right. So as usual, great stuff today, Jeffrey. We'll keep this up for next week. Take care.
Bye. Thank you so much.
No problem. Bye bye.
Bye.